Hello everyone. Thank you for being ready to listen my research presentation. My name is Yongtae Kim or Tate Kim, and the topic is PTSD affiliated behavioral variance in avoidance and discriminative learning. There is three type of keyword: PTSD, behavior, and learning. And there is two types of learning: avoidance and discriminative. Avoidance learning is a learning to avoid from the hate something to hate, and discriminative learning means the ability to distinguish the cue that hate or like. So let's start the presentation. The motivation was PTSD. What is PTSD? PTSD is a post-traumatic stress disorder. That is a disorder that happens when the subject gets traumatic stress or some event. And also this PTSD is related with various harmful concepts such as anxiety, stress, flashbacks, depression, fear, fight, and suicide. Previous literature says there is some identifiable vulnerabilities exist that increase the risk for development of PTSD, and also some individuals show learning-related enhancement in the PTSD. So during our subject is a mouse, we should measure the PTSD level on the mouse, and luckily there is a method to measure the PTSD level on mouse. Elevated plus maze, EPM is it. It is a widely used behavioral assay for rodents, and it can measure the anxiety-related behavior to get some PTSD level on mouse. Another literature can see that there is some result from EPM can distinguish PTSD and non-PTSD mouse with the result of EPM. And also there's the figure D is saying there is a difference on generalization index between PTSD and non-PTSD mouse. That means that the distinguishing ability is different between them. So the question of my research is two researches. How does PTSD affect the proficiency of avoidance learning in animals? And also, how does it impact their ability to distinguish between aversive learning tracks with and without reward? To do this research, I prepared several experiments, and one is the single prolonged stress, also called SPS. That is a protocol to make some PTSD on mouse. There is several steps, and in this research I made 3 controls and 5 treated mouse. First step was 2-hour restraint. Second step, 20 minutes forced swimming. Third step, 5-minute ether anesthesia. During these 3 steps, the mouse get traumatic stress, and after the 4th step, 1 week rest, the mouse can get PTSD from the SPS protocol. And the next experiment that I did is a EPM, elevated plus maze. We can measure the PTSD level with this EPM. To do this, I record 5 minutes during I put the mouse on the center of the EPM, and EPM has 4 arms and 2 open arms and 2 closed arms. 2 closed arm has a wall around the arm, so the mouse can feel comfortable in there. So if the mouse have a long time in closed arm, we can say, oh, the mouse is have a big anxiety level, so that the mouse has a PTSD related behavior. So, and then there is a main experiment. Then we can measure the avoidance and discriminative learning with virtual reality track. In this experiment, we used virtual reality with mouse, and there's some virtual tracks on the mouse, and we can measure the speed or other variance to distinguish what happens on the mouse between PTSD or not. Okay, first track and second track has a different color, but the main structure is similar. There is a beginning zone and shock zone and safe zone. Beginning zone is all of the zone is basically closed loop. That means when the mouse run, the virtual track move to the back, so that can make mouse can think it is walking. But in beginning zone, if the mouse don't move, then the track become open loop and move automatically to the back. That makes mouse goes into the shock zone. And in the shock zone, the mouse gets electric shock to the tail for 1 second. And if it doesn't move at all, the shock is given in 3.5 second interval. This is the same structure of two types of track, but the rear track which give reward has a reward zone after the shock zone. The reward zone in the reward zone, the mouse get water as a reward after 1.5 seconds after it exits the shock zone. So we can know how the mouse distinguish these two types of track with or without the reward. Among all these experiments, I make some timeline with all of the experiments. First, I measured before and after 2 days of SPS. That can make how the anxiety level of mouse is measured. And also, after the 7 days from SPS, I started to measure EPM and VR track, the main experiment, to measure the anxiety and PTSD level, and also the learning level. And before the starting of main experiment, I 2 days before the experiment, I stopped to giving water to mouse to make them thirsty, and it means they feel water as a reward in the track. You can see this video. And then let's talk about the population result. The population result has a distance moved and mean velocity, and the x-axis means that day 2, -2, -1, +1, 2, and 7, 8, 9 that we measured at the EPM. And also this y-axis mean distance moved and mean velocity on this graph. The red thick graph means mean controls and standard deviation error bar, and the blue one is treated groups mean and error bar. So as you see the result, both of the graph has a tendency that control group is higher than the treated group. That means the control group moved more, longer, and more faster. And also, this tendency is consists on after SPS. However, the difference between the control group and treated groups are not really big, so we cannot say there is a statistically significant difference from these two groups' data. Next graph has the same x-axis x-axis, but the y-axis is different. The left one is duration proportion. That means duration that the mouse is on the open arm divide by open arm time plus closed arm time. So if the graph is higher, then it means the mouse spend more time on the open loop, open arm. That means it has low anxiety. So as you see this graphs on the day 1 and 2, the two groups data is similar, but after the 1 week, the control group and treated group's difference are more bigger than before. But anyway, the difference is similar either, so we cannot say it is statistically significant. Next, let's go to the VR track data. I prepared the two types of I treat each one mouse on each control groups and treated groups, and in these plots you can see the speed. You can see when the speed is faster, then you can see the color is more yellow, and also you can see there's the speed is higher in the shock zone. That means the mouse ran faster to don't get electric shock on the shock zone. And on the left lower plot, that is a leak plot, that how mouse leaked from the reward zone. And after the next day, the same mouse ran very well, and also we can see there's some anticipatory speed before they enter the shock zone. That means this mouse is learning to avoid the electric shock. That we can see this mouse is getting avoidance learning. And also there is some leak data is getting higher when the water came, and we can see the anticipatory leak before the water came out. Then if mouse leaked before water came, then we can think, this mouse learned when the water came out. And the next day, as you see, the anticipatory speed and anticipatory leak is getting much higher than first day, and also the speed on the shock zone is became very stable. That means this mouse is avoiding the electric shock very well, and this tendency is same on control and treated group, but we should see another part of the tendency of each comparison of control and treated. So let's see the population result of the VR track. As you see this plot, the control has an anticipatory speed, small anticipatory speed on day 7, and very high speed on the just entrance of the shock zone and just before the exit of the shock zone. That means they got shocked at that time. That means they didn't learn well. And however, treated group has similar tendency, but they have anticipatory speed and exit peak lower than control group. That means they are learning better than control group at first day. But then in the day 8, after one day after day 7, they have more. Control group has more anticipatory speed, and the treated group's anticipatory speed is has a slightly different from the day 7th. On day 8, after the 8, when the night day 9, the control group and treated group has a population graph in here, and the anticipated speeds of control group became more higher than before. And then treated group has anticipated speed too. And also we can see the percentage of sessions subject to electrolytic shocks, the proportion of what session that got electric shock or not. And as you see, they have different small difference in the first time of the measurement, but we can see the naive mice that didn't get PTSD SBS are learning more than SBS mice. And lastly, we can see the population result of the anticipatory speed and anticipatory leak and compare them with the control and treated group, and also rearward track or not rearward track. And as you see this plot, the control group's data is going up day by day, but treated groups is not. That means control group's learning is very good, but treated is not. And the anticipatory leak has showing similar tendency on here. And however, in the treated groups data, anticipatory leak has a bigger difference when the day goes. Then we can think the discriminative learning is more getting induced in PTSD mouse. In discussion, we observed increase on anticipatory speed and leaking over the time in the control groups indicate effective avoidance learning. However, the treated group shows a reduced or even negative increase, suggesting impaired or slower avoidance learning progression compared to the control group. Interestingly, the treated group demonstrates better learning in distinguishing between the presence and absence of the reward. A larger sample size is necessary to archive significant differentiation of PTSD using EPM. In conclusion, increasing the sample size would yield statistically significant results in EPM for PTSD differentiation. Future studies could test whether PTSD specifically impairs avoidance learning while enhancing discriminative learning. And the main point that I wanted to do originally is measuring the neural data, such as dopamine release could reveal changes in temporal difference reward prediction error model, or TDRPE theory, in the context of PTSD. These insights could enhance our understanding of PTSD, neurobiological mechanism, and guide targeted intervention. I have special thanks to Miju Park, who helped me designing experiment and teach me how to do Fourier track, also helped me data analysis. Seung-Yup Lee and Jabin Yoon helped me to do SPS. Jung-Hee Lee teach me how to do EPM. And thanks for all to Professor HyeongGoo Kim as a PI. Thank you for listening, and contact me if you have any questions or opinions. This is my emails, and there's some raw files in G Drive and Y Drive in MATLAB, and you can find my raw data, raw videos, and other statistical data in these files. And if you want to use or see these files, I made some change the names of each data names to this in this rule, so you can see the data with this index. And these are the Fourier track session names, and you can find it on the Y drive. So, and then you can use my data to do anything. Thank you for listening my presentation, and if you have any question, please contact me on email. I was Yongtae Kim. Thank you.